Hi, welcome back to my channel. Well, in this video we'll try to learn how we can create dot and whisker plots for regression analysis utilizing a very important library, rather a very famous library as far as data visualization is concerned, that is known as library ggstatsplot. It creates wonderful and interactive plots, and I have already made some of the important videos in context to test of significance, analysis of variance, including design of experiments utilizing this library ggstatsplot. The idea is to plot regression coefficient point estimates as dots, like a plot which is available on the right side of the console of this RStudio. So instead of showing the results or the output of a regression model in numerical way, we'll try to make a plot, this kind of a plot, where all the individual regression coefficients along with your estimates and p-values and with certain amount of statistical details will be available, which looks quite elegant and interactive in comparisons to the normal numerical traditional way. So in order to begin, let us proceed. First we need to recall the libraries. The first one is library ggstats and library ggcorrplot. So let us click on this run. Then the next step is to import the data. I have already a data set which is available on my desktop. I will use the traditional way, that is click on this import. Then I will choose in which format my data set is. Since my data set is in the form of Excel, I will click from Excel. After that I have to click on browse data. Since my data set is available on my desktop and the name of my data set is MLR, I will click on this open. Then it will get reflected here. Once it will get reflected, then I have to click on this import. So the data set has been imported. It has got 32 entries. That means there are 32 observations in this data set, you can see. And we have 4 columns, first, second, third. The first 3 are my explanatory variables, and this, the last one, that is yield, this is my variable of interest, this is my dependent variable. So I want to fit a regression model, rather a multiple regression model, on this data set where yield is my study variable or response variable. But before fitting or making this kind of a plot, let us try to see what kind of linear relationship or what kind of correlation exists between all these 4 variables. For that is ggcorrmat. So actually it will create a correlation plot. Then within this I will write the name of the data set, then click on the center. So within fraction of seconds a plot will be reflected on this side, and you can see here the sample size is n is equal to 32. That means the total number of observations per variable are 32, and Pearson correlation, it ranges from -1 to +1, and the green color is reflected, shows us there's a positive relationship between a pair of variable, and this lemon type or yellow type reflects there's a negative relationship. And the good thing about this plot is that means these crosses, they reflect the non-significant correlation. And if we will take an example of yield with respect to years, it has got a positive correlation. And another important detail about this plot is that the more denser the color is, the more stronger the relationship, or it shows the strength of the correlation. So let us first fit the model on it. Let us fit the model or regression model on this data set. Let us first write names. The name of my data set is this. Let us see the structure also, that is MLR. All these variables are numeric in nature, and I will want to see the dimensions of my data set. You can see there are 32 variables, 32 observations and 4 variables. So in order to fit a regression model on this, what we need to do, we need to first use this function, that is set.seed. It actually creates the random numbers that can be reproduced. So actually it is help us in creating the same random number whenever this random function or this random function is recalled. Set.seed 1 2 3. Okay, so let us first fit the regression model. I will write a name to this, and I will utilize this default function, that is lm, and within this I have to create a formula. For that I have to first write the name of the dependent variable, that is yield, followed by tilde sign dot comma. Either I have to write the name of each and every explanatory variables. I have to write years, length, weight also. So instead of writing all these variables, because sometimes it will happen, you may be having a data set where there are 10, 15, 20 number of explanatory variables. So instead of writing the name of each and every individual explanatory variable, I will simply write dot comma, then the name of the data set, that is MLR. This is actually the traditional way of fitting a regression model. Here we are not interested to see the output of the regression model in numerical way. We actually want to put this output on a graphical way, in a graphical way. Let's click on the center. Then after that, what we have to do, we will write summary, the name of this function which I have just written. So this is the output of my data set. So you can see this is a traditional way of seeing, but our main objective here is we want to put these estimates on a plot. For that, what we will do, we'll write ggcoefstats stat. Then within this I will write the name of this function, that is model, and let us give some name to it, that is plot model is equal to, then I will write plot model only, then I will click on the center. We will get a plot here. You can see, now see the difference. There is no difference between, let's try to zoom it out first. Now you can see here on one side, on vertical axis, we have terms and we have estimate, and we have the values of some selection criteria like AIC and BIC. Now let us go to this side. You can see the value of the intercept is 32.84. You can see the value is 32.84 with 28 degrees of freedom on each and every variable. And this is the estimate or the t value. You can say it is 0.50, you can say it is 0.50, and the p value here is 0.62. You can see the same information, instead of showing the output of our traditional multiple or simple linear regression in this way, better is to put the results of this regression model in a graphical way, which looks quite elegant and interactive, and it will definitely help whenever someone is writing a research paper or someone is trying to show his or her results which are in the form of regression model in a conference or a seminar. I think this will definitely give some, I think it will definitely help the end user, whosoever is using this library, because you can see if we will take the example of years, the years is the regression coefficient for years is 0.04, or we can say the partial regression coefficient is 2.04, and it is significant. It is 1 to 1.20 e raised to power minus 0. This which is in the exponential form. So it is less than 0.05, the traditional p-value which we used to take as a standard. And you can say years have a significant effect on this our yield in this example, and you know how to interpret it. That means whatever the unit of these variables, if there's an increase of 1 unit in this variable, the yield in this example will increase by 2.04, whether it is gram, whether it is kg, whatever the measurement of unit which has been used in the particular data set. Similarly, you can see the weight, the coefficient of weight is minus 7.39, and you can see the t-value is minus 1.2, and same is the case with this. Take the example of length also, it is minus 0.21, and you can see the p-value, same amount of information has been reflected. So in order to show the results in more elegant or interactive way, try to utilize this library ggstatsplot, because it creates some of the wonderful and interactive plots. Like I have made a lot of videos regarding the implementation of this library. Hope you will like this video. I will give the functions or the codes of this example in the description of my video. Thank you very much.